Welcome to Mikab College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Hello students, welcome to mathematics class. I am Ms. Sibera Favor and I'll be taking you on numerical processes, and the topic before us is number bases. Previously in your GSS classes, you were introduced to number bases, particularly the number 2, which is the base 2 numbers. But in this lesson, we'll be looking not just at the base 2 numbers, but other bases, which includes base 4, base 5, base 8, even bases greater than 10. So, and after this lesson, you were expected to be able to convert from one base to another, from any base at all to base 10, and from base 10 to any other base. Now, we will start with a recapitulation of what you did earlier. We are all conversant with the base 10 number, such that when we have 2, 3, 8, 9, this is a base 10 number. We will conclude that the first two, the digits we have there, the first two there, is for 1,000, 2,000s, then 3, 300s, 8, 10s, then 9, the unit. Now, how do we arrive at this conclusion? By expanding this number in the power of its base. Now remember, this is a base 10 number which we are used to. So I have 238 base 10. Now I will expand. How do I expand? I expand by bringing each of the digits, multiply them by the base. Then adding it to the next digit, multiplied by the base, plus this last, the other digits multiplied by the base, and the last digit. And mind you, when you have a group of number, irrespective of the base, the last digit you have is always the unit. And after multiplying each of the digits by the base, I will give power. And from the units, I will start from 0. To the second one, I'll give 1, then 2, and 3. And if I have the numbers to be more than 4 digits, I'll keep numbering them that way. Alright, so from here, we will arrive at 2 times 10 raised to the power of 3 means 10 times 10 times 10. As many students do mistake 10 raised to the power of 3 to be 10 times 3, it's not. 10 raised to the power of 3 means 10 times 10 times 10, and you have 1,000, plus the second set will have 3 times 10 raised to the power of 2. 10 raised to the power of 2 will give us 100, which is 10 times 10. That is 10 multiplied in 2 places. Then the third, we have 8 times 10 raised to the power of 1. And 10 raised to the power of 1 is 10. And lastly, we have 9 times 10 raised to the power of 0. And that will make us refer back to our laws of indices, the zero law, which states that when you have a number raised to the power of 0, provided the number is greater than 0, then it will be equal to 1. So this 10 raised to the power of 0 is here to be equal to 1. So from here, this has proved that this interpretation is totally right, as this becomes 2,300, 810, and 9 units. Remember, I said the last digit of every group of number, irrespective of the base, is always the unit. Now, this is expansion, and this expansion has given us the exact value that each digit stands for. Okay? So, now this can also be done in any other base. It is possible to expand any other base having the exact value each digit stands for. Okay? That's what we're talking about. X raised to the power of 0. when x is greater than 0, it's equal to 1. So conclusively, the 2 in that set of number has a place value of 1,000, 300, 10 units, 8 tens, and 9 units. So as I said, it is possible to expand any number at all in any base. So we'll look at 121 base 3. 121 base 3. And mind you, I'm calling it 121 because it's not a base 10 number. I cannot call it 121. So it's 121 base 3. And like I said earlier in the base 10 example I gave, that when expanding to know the exact value of a digit in a group of number, you multiply each of the digits by the base in which they are given. So here I have 121 base 3. It will be equal to 1, that's the first digit, times 3, the base I'm working with, plus the second digit 2 times 3, the base I'm working with, plus the last digit 1 times 3, the base I'm working with. And I said that when you're given power, starting from the last digit, which is always the unit place, you start 0 here, 1, 2. And if at all I have other numbers, I'll keep giving power 4, 5, and so on. So that will take us to simplifying further. 1 times 3 raised to the power of 2. Remember, it doesn't mean 3 times 2. It means 3 times 3, 3 in 2 places. So 3 times 3 would be equal to 9, plus the next set now. 2 times 3 raised to the power of 1. 3 raised to the power of 1 is 3. Then plus 1 times 1. Remember, our 3 raised to the power of 0 is 1. So I have 1 times 1 there. So this has also given us the place value and the exact meaning of these digits. So we can also say this is 1 9s, as we had 2,000 earlier. It is possible to have the place value of this 1 9s, 2 3s, and 1 unit. So having known how to expand and you're able to figure out the exact value of a digit in any group of number, then you have no problem with conversion. So as long as you're able to multiply through by the base you are given, then give power starting from the last digits you have, 0, 1, 2, and so on. Then you simplify further, you have no problem with conversion. Okay? So now we are, okay, before we go to conversion, we have to take note of this, that the greatest digit in any number is 1 less than the base number. Now what we are saying is, if I say I have a base 5 number, a base 5 number can only contain 5 digits, and that 5 digits you start counting from 0. So if I have 0, okay, like I have there, 0, 1, 2, 3, 4. Now, despite that, the greatest digit I have there is 4. The numbers of digits, including 0, has already given me 5 digits. So in base 5, the only set of numbers you can have includes 1, 2, 3, and 4. Now, like this, if you're having 2, 0, 3, 5 to base 5, it's improper. There's nothing like that, because the greatest digit, which is 5, is already equal to the base you're talking about. So this is no longer in base 5. It could be base 6 number, base 7 number. Remember, we said the greatest digit in any number is 1 less than the base. And here we have 1031 to base 2. You can see it has been cancelled, and it is given the caption not doesn't exist. So you can't have 1031 to base 2, because the 3 you have there is already more than the base. Remember, the greatest digit in any number is 1 less than the base. So we conclude that 1023 can be found in base 5, while 0 and 1 which is 2 digits, are just the digits that make up any base 2 number. So I can't say I have a base 2 number and I'll be having the digit 3, the digit 2, 4 in a base 2 number. All that a base 2 number is made up of is 0 and 1. Okay? Now, and we have only 10 digits, which are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 in a base 10. In base 10. Now, we ask the question, what happens when we have a base greater than 10? What do we do when we have a base greater than 10? That is, maybe when we have to work in base 11, base 12, base 13. What happened? Because in this case, this will be read as 2035. This will be read as 1031. Now, if I have a base 11 or base 12 number, that will be including 2-digit numbers. Yes, it will include 10 and it will include 11, 12. And by the time I write 10, a student will not read it as 10. They will read it to be 10. So there arises a problem. But we should not be scared, because when there is a problem in mathematics, we always run to our neighbors in English class. And they will be worrying us their English letters. And most times we don't always ask. We just go take them, or better still, we steal them. So here we have alphabets to be representing the 2-digit numbers. So A, the alphabet A, remember I'm using the uppercase. A equals 10, B equals 11, C equals 12, D equals 13, E equals 14, and F equals 15. Mind you, this doesn't stop here, it continues. But for this class, we'll be stopping at this point. So your business now, since English class has helped us, your business as a mathematics student now is to be able to master these things, such that when you see A, you know what it means. When you see B, you know what we're talking about. So that is that. You should know that A stands for 10, 11, B means 11, and so on. Now, to the business of today, conversion of numbers from bases. That is from base 10 to any other base, or from any other base to base 10. It is very possible to convert from one base to another. Just as you know, if you have hot water in your house and you want it cold to drink, you want the water changed. Yeah, you can simply put the water in the refrigerator for it to be changed to suit your purpose, what you want. So if I have a number in base 3 and I want it in base 10, it is very, very possible and very easy for me to convert it. So that's what we're going to look at. I have an example. Now we're going to convert A, 631 base 8 to base 10, and B, 7335 base 10 to base 5. Please look at the question very carefully. I have A, 631 base 8. 631 is presently in base 8. It's a base 8 number. Now I want to convert it to base 10. Then the second question, 7335 base 10 to base 5. Okay, this is a base 10 number and I want it converted to base 5. Okay, I have another question, AB3 base 12 to base 10. Then 1575 base 10 to base 12. Remember, from what we borrowed from our English teacher, A equals 10 and B is 11. So don't be confused or scared when you see AB3 base 12. Alright? So let's look at how we do this together. 631 base 8 to base 10. Now there are two ways to approach this question. One is called the expansion method, which we were introduced to earlier. the way we expand to get the exact value of any digits. Then, okay, first we are going to be applying that method. I bring one of each of these digits that I have in base 8 and multiply them by the bases. Please listen up. I have 631 base 8 to base 10. I am going to expand this. Remember the expansion we did earlier. So I am going to bring each of these digits multiplied by the given base plus the second digit multiplied by the given base 8, plus the third digit, which is the last one, 1 multiplied by 8, the given base. And I start giving power from the units point, which is 0, 1, and 2. So from here, I simplify further. Now the only difference or the slight difference between just expanding and converting to base 10 is when you expand, you don't just leave it like that. You simplify further till you have a single answer. And that single answer becomes your base 10 answer. So I have 6 times 8 raised to the power of 2 plus 3 times 8 raised to the power of 1 plus 1 times 8 raised to the power of 0. So 6 times 8 raised to the power of 2 will give me 64. Remember, 8 raised to the power of 2 means 8 times 8. So I have 64. Plus 3 times 8 raised to the power of 1, 8. Plus 1 times 8 raised to the power of 0. 1 times 8 raised to the power of 0 is going to give me 1. Remember, anything to the power of 0 that is not 0 is 1. Okay? So now I'm not going to just stop here like we did in the expansion earlier. I am going to simplify further to have this very number in base 10. So if I multiply 6 by 64, I will have 384. I'm very sure you are trying it out on your own. 384 plus 2 times 8. I'll have 24 plus 1 times 1. I'll have 1. And I'm still not going to stop there. I will add everything together to give me 409 to base 10. That means I've successfully converted 631 base 8 to base 10 since I don't want it in base 8. So I converted it to base 10. So 631 base 8 is the same as 409 in base 10. Now we solve using the repeated multiplication method. Now in this repeated multiplication method, I have 631 base 8. Remember, we're working in base 8. This method, you repeatedly multiply each of the digits by 8. Like this is my first digit. I multiply by the base I'm working with, 8. I have 48. Then I bring this down, plus what I have earlier, the 48 plus the next digit, 3. I'll have 51. Multiplied by 8 again. That's why it is called repeated multiplication. You keep repeating, multiplying by the base you're working with. So I have 51 times 8. I'm going to have 408 plus 1 is going to come down to be added to 408 plus 1. Then I have 409 base 10. So either method you prefer or you understand better, you can always use in converting from any base at all to base 10. Okay? Now, 7, 3 to 5 base 10 to base 5. Remember what I did earlier? That I used the expansion method and the repeated multiplication method was converting from other bases to base 10. Now I'm converting from base 10 to base 5. Now what you do when converting from base 10 to any base at all, you bring that base 10 number you have and keep dividing it by the base you want to change into. Please listen again, it's displayed, repeatedly divide 7335, which is the base 10 number we have, by 5. This 5 is the base we want to change into. So we are going to keep dividing it by 5. And we are not just dividing by 5, we are writing down the remainder. Please take note. I will keep dividing that base 10 number I have by the base I want to change into. Then I'll keep writing down my remainder. So let's look at what we have. I have 7,335 to base 10 to be changed to or converted to base 5. Now, I bring my 7,335, then I divide by 5 like our normal long division method. I divide by 5, 5 into 7,335, I'm going to have 146, remainder 0. Now take note, despite that 5 divided completely into 7,335, that there is no significant remainder, it's remaining 0. We will still have to write that because in base there's digit 0 markers a lot. We are not going to ignore that. So I'll write my 0. Then 5 will also divide again 1467. 5 in 1467, I will have 293, and this time we have a remainder of 2. Again 5 will divide 293 again, and I'll have 58, and this time I will have a remainder of 3. You see the way I'm writing the remainders down. Now 5 will also go into 58. I will have 11 and a remainder of 3. Then 5 into 11, I'll have 2 and a remainder of 1. Now 5 into 2, obviously 5 cannot divide 2 completely, so we'll have 0, remainder 2. Now, how do we arrive at our answer? We will not start reading from the top to the bottom, just like we used to climb the tree. I don't know if you've seen anybody climbing the tree. You start from the bottom, then you climb up. So that's the same way we are going to read our answer, from down the bottom up. So instead of having 023312, I am going to start from the bottom such that I will have 213320 to base 5. Okay, so the last set of example. So conclusively, 7335 base 10 equals 213320 base 5. Now, our letters are here again. We have to convert AB3 base 12 to base 10. We are converting from a base that is not base 10 to base 10. So we are going to simply use our expansion method by multiplying each of the digits by the base, giving power from the unit, which is the last digit, 0, 1, 2, and 3. So I'll have A times 12 raised to the power of 2 plus 11 times 12 to the power of 1 plus 3 times 12 raised to the power of 0. Remember, our A is 10, our B is 11. So 10 times 12 raised to the power of 2. 12 raised to the power of 2 is not 24. It's 12 times 12, so you have 144. Plus 1 times 2, 12 raised to the power of 1, 12. Plus 3 times 12 raised to the power of 0, 1. So I'll keep simplifying further. 10 multiplied by 114, I'll have 1440, sorry. Plus 11 times 12, I'll have 132, plus 3 times 1, I'll have 3. Then adding all we have together, I'll have 1575 to base 10. Now, quickly want to try something. We want to try convert this 1575 back to base 12 and see what we will have. So remember, we will continue to multiply by 12 because divide by 12 because that's what we want it converted into. So 12 into 1575, it's going to give us 131 and we'll have a remainder of 3. 12 in 131, I'm going to have 10, remainder 11. Then 12 in 10 is going to be 0. Now have a remainder of 10. And as I said, as we climb tree, we start from the bottom up. Then I'll read my answer upward. I'll have 10, 11, 3. And what we were saying earlier, if I should try writing this in the figure form, it's going to be read as 10113, am I right? So that's why we had alphabets there to help us out. So we have A, B, A which is our 10, B which is our 11, and 3. 3 can stand on its own since it's not a 2-digit number. So we have A, B, 3 to base 12. This is where we'll be stopping for now. In our next class, we'll be looking at how we can add and subtract using different bases, how we can add and subtract in different bases. See ya.
Thank you for taking your time to watch this presentation. We hope you have made some new discoveries. Please take time to watch other related videos from Mikab College on this platform. You can also study the transcript of this very lecture by clicking the link below. If you enjoyed this lesson, please like the video. If you are yet to subscribe to our channel, please go ahead and do so. Feel free to share our videos to your friends and ask them to subscribe to our channel. Wishing you success in your career. Bye for now.